Hi, everybody. Welcome. Happy Monday. I'm still letting a few of us in, but let's go ahead and have attendance check question, which is when is your B day? Go ahead and put that into the chat so I could double check our attendance. Right. All right. We got a few birthdays that already passed. Awesome. Right. Wow. Okay. So a lot of us are in the springtime. Some in the summer, some already passed. Oh, September. A recent birthday. Majority looks like it's in the springtime. Awesome. Wow. So a lot of September ones have passed. Happy belated to those who were in September. All right, let me see who I have here. Oh, okay, James is here. Cool. Mine's also for those who are October. I think there's like 2 Octobers or just one. Sophia's October. Yeah, I'm also October. I'm October 29. Mine's near Halloween, so mine's coming up too. Awesome. A lot of us have passed here in the September. I don't meet a lot of October babies. I don't know if that's just, me or what. Oh well. Okay, so let's see. Just who I don't have, and again, you can let me know if I'm have an error or anything. I don't have Kaylin with a C. Um, I don't have Edgar, Fernanda, Grecia. So that's who I don't have. Let me know if that's an error or I missed somebody. So again, I'm missing Kaylin with a C. I'm missing Fernanda. I'm missing Edgar and Grecia. So if you're friends with them, if you could let them know, send them a. I think we got Edgar now though, so yay. So we're just missing Kaylin with the C, Fernanda, and Grecia. So three. Awesome. Let me go ahead and put that into the attendance here. Um, all right, cool. No problems, Edgar. Welcome, welcome. All right. So let's jump into our agenda today. So we had our attendance, a little check-in. We're going to be doing a group problem today. It's going to be a short one, like a 10-minute group thing. It's going to be a Padlet where we kind of synthesize our big ideas. Then we're going to move on to notes. So the notes is going to be finding average velocity on a velocity graph, which is actually different than what we did last time when we calculated average velocity. You'll see what I mean once we hit there. Then we're going to have a checkout. Asynchronous number 6 is now posted. It is due tomorrow. By the way, if you have any missing assignments for AP Calc, please make sure you get them in. Let me know how I could work with you, on getting any of the past assignments in, but they're super important because, some of them, especially the Khan Academy one, they're filling in some gaps that we're not talking about in class. So super important that you get those in. Again, what matters to me is learning as opposed to the deadlines, but you want to make sure that you're not letting the work pile up as well. We're in the third week right now of the module. And then after this week, we just have like 2 days next week. So I just want to make sure I check in with those students who are missing some work. Just please make sure you get it in, make some time for it, and so forth. Just let me know if you need any extra support. You could also jump into my office hours. I have them Monday through Wednesday at 10. And I'm happy to work with you on anything, on any of those assignments. All right. So, yeah. So, there we go. That's our agenda. Let's jump into it. So, the group problem. Here's some stuff. So what will be the goal or the purpose of the group problem? The learning goal is applying our big ideas on motion graphs. Now, some of you already made these connections because I was kind of looking at yesterday's submissions, Sunday submissions on last night. I was looking at it through my phone, and some of you already are applying like the big ideas and making connections about the motion graph. So for some of you, that might be like what you do again here today, but with your group. You may be able to share your knowledge and so forth for those who have not yet made those connections. Again, we're going to be put into random groups for about 10 minutes. It's going to be a short group activity, and then we're going to move on to our notes. We'll see. Sometimes the group activity takes a bit. The goal is you're going to be working together. You're going to annotate and label your graphs, justify your work, use annotations, maybe even use color coding. I'm going to show you all how you could do that on the Padlet. I actually didn't know you could do this, but you can. When I jump into your group, I should be seeing a screen sharing plus any discussion and explanations. So yeah, so if I jump into your group, sometimes I just jump in. Again, I'm not jumping in to get like a rehash of what y'all are doing. I might ask if I'm confused, but usually I'm just in there to see the discussion. Not really, you shouldn't owe any explanations or anything. I'm just there to just see what's going on in the group. But feel free to share if you'd like to, like what y'all are doing, or I might prompt, like ask you all, like, hey, what are you doing if I'm a little bit confused? And then quick thing, again, if you have any anxiety, or you feel like uncertain about, doing the work, just a little motivational here about like, number of failures before successes. There's like a lot of examples. And by the way, when I first did some of these problems in this textbook that y'all are doing now, it's like I got them wrong the first time. The point is, um, it's okay to get stuff wrong because that's when you learn. If you're getting stuff right all the time, that's a little bit sad because you're not learning, right? You're just getting stuff right. You're like, okay, I already knew this, right? So it's less fun if you kind of already know it. Again, failure is totally the expectation. Like the most successful engineers, fail a lot of times before they actually reach success. So that's fine. If you feel like, oh, I'm not getting it, that's the point. You want to just keep trying, ask your group mates and so forth. So it's okay. Just be comfortable with not knowing and be comfortable with asking questions. It's just a little bit of tip for y'all. So that's that. So don't feel like negative or anything like that. Should not feel negative when you're learning. All right. So before y'all head into your random groups, right? I want to first have you take a look at what you're going to be doing in the Padlet first, individually. So this is so funny. So it says Frito, short for Alfredo. I've never heard that short for Alfredo, but okay, that's okay. Usually we call them Freddy or something. But anyways, Frito, short for Alfredo, and Frida were both given the responsibility to collect data for a foot race. After watching the event, Frito and Frida gave the coach graphs of their data shown below. So here's Frito's graph, and here's Frida's graph. So they both kind of gave two different graphs to the coach, and he's a little bit confused. Notice that neither of them have their axes labeled, so it's like confusing what they're actually recording. So the coach is dismayed because the graphs are different. However, though, Frito and Frida know that they watched the same race and their data is confirmed in each other's graph. So they are collecting the same data, but they're just representing different things. So your goal is to help convince their coach that the graphs actually do represent the same race. So in your group, you're going to do part A. To help the coach understand the graphs, you're going to label each graph with the appropriate and reasonable units. So again, the x-axis, y-axis, what are reasonable units? You get to decide that. And B is explain how Frida's graph confirms Frito's. So how does her graph confirm Frito's? And vice versa, how does Frito's graph confirm Frito's graph confirm Frida? It's a little hard. Their names sound so similar. So you're just like, how do they confirm each other is part B. So that's the goal for the group activity. But right now, let's go ahead and take 2 minutes for you to independently process this or for you to independently work this out, before you head over to your group. Let's take 2 minutes. All right, everyone, welcome back. I hope you got some time to process this problem a bit and know a little bit of what we're doing. Um, Also, feel free to ask any questions, by the way, in the chat or verbally about any clarifications on the situation, the context of this problem, but not like how to solve it. The how to solve it, I want you to figure out how to answer it. I mean, is what I want you to figure out with your group. So let me show you though how I expect your group to create your answer for this. So it's going to be on a Padlet, but I'm going to show you. Whoops. Boom. So in a second, I'll be giving you all the link to the Padlet. But on the Padlet itself, you have the problem there. So like you don't have to kind of switch screens. Like once you're in your group, someone could go ahead and share their screen of the Padlet itself, and you could click on the problem and be able to see it big. But here's how I'd like groups to show their work slash show any annotation. So you're going to click on the plus symbol. So now here, notice it says uploads, link, even like a picture, right? I mean, you could do a picture if your group is able to do that. It's a little bit harder, but if you go to the more, there's like much more you could do. You could draw. So the one I want us all to use is draw. If you click on draw, it's cool because you could draw the two graphs that we're looking at. So for example, I think this was, and by the way, I cannot draw straight for whatever reason. Anyways, but this was, I think, Frodo's, and then you could do Frida's. Whoever has the most stable hand maybe wants to do this part. But you could go ahead and answer part A like that, and then part B on the Padlet like that. Just try your best to make it as legible as you can. I understand because as you can see, my penmanship is really bad. But that is how I'd like us to go ahead and like show our work as a group and to make any annotations. So if you look here, you could you can add color. You could, in order to show what you're doing, um, you could add color. You could do your labels, whatever, seconds, time. I don't know, however y'all are going to interpret it. There's even an eraser, so forth. So yeah, so that's what I'd like you all to use as a group. So whoever's screen sharing to do the annotations, and as you all are sharing your ideas and so forth, the person screen sharing can make sure that gets jotted down. And this is going to be for about 10 minutes. Let me go ahead and I don't want to save that, so I'm going to trash that. And it's going to be one response per group. So at the title of it, just make sure you put your names. All your names are on there for your credit. Let me go ahead and get the link for you all. Here is the Padlet first, and then I'll go ahead and do the groups. There's your Padlet. Maybe somebody wants to, once you have the Padlet, you could go ahead and see how you could test out the, how to do that drawing tool. That's actually pretty cool. I had no idea we could do that. So give me a sec as I create these rooms. Yes. Okay. All right. Let me open up the rooms, everybody. Evie, were you able to get did you get a notification to join the group, Evie?
I'm gonna be sharing my screen. Um, so when I did do the problem in the time that she gave us to do it, and I realized which graph was which because I saw that for I think it's Frida's graph, she doesn't move at all. She just kind of stays in the same place. And I saw that for Frito's, he does move, and it has even a marker that's 90. So I'm pretty sure Frito's marks the position and times the time, while Frito's does the velocity in time. And I think that the velocity stays constant basically the whole time because otherwise her graph would be going up and down, Frida's. So I think Fritos is the position and Frida's is the velocity. I'm pretty sure. I think pretty sure. Yeah, yeah. Fritos is the position. Frida's the velocity. I think that I would label Fritos as time for the 18 seconds, and then the top would be meters, position or distance, whichever one you want. And then for Fritos, I'd say it'd be time and then velocity, meters per second, because I think she goes 5 meters per second every second. For B, I think that Frida's confirms his because if you multiply 5 times the 18 seconds that they travel, that's 90 meters that Fritos travel. And looking at the flip side, if Frito travels 90 meters in 18 seconds, you can do the exact same thing, and you can find that every second she traveled five. For in Frida's graph, they traveled 5 meters. That's 90 as well. So they both have sort of the same endpoint. You just have to use math to find it. It's kind of like what we did with one of the first things we did, like the breakout rooms for the first day, where we had to find like the total distance traveled. You kind of just figure out how much they're traveling for every second, and then multiply that times what they're traveling, and that's basically how they prove each other. Does anybody else have any ideas? That's what I got for that.
That makes like perfect sense. So I don't. Yeah.
I think the homework that we were supposed to do really helped understand this too. Because when I did it, I kind of created my own graphs and try to use them to explain it. But this is basically what, like, if you haven't even done the homework yet, I'd probably suggest doing things like this. That way you can really explain it. Because then it's like this is 90 and this is 90. They both end at the same time. That means they're equal. You know, because I'm sharing, I think I'll just be the one typing. For Sedona, what do we type exactly?
So now, I mean, I heard you verbally describe, right, the connections and so forth. It would be awesome if maybe someone in your group also has any ideas on how to kind of color code kind of what you were saying. Like you were kind of like saying about how each confirmed, you're saying like blah blah times blah equaled, the 90. So you were making your connections there. Color coded and just go ahead and answer part A and then part B where it says down there. Awesome. And by the way, Juan, you also have some stuff in the chat. So there's some feedback from your group in the chat as well.
Really? I can't see
Yeah.
it. Oh, there you go.
Yeah.
I don't know. I don't really do screen sharing, so it's like hard. I just
Yeah.
click it, but it won't show up.
Yeah.
Oh, there you go. Oh, okay.
Like your
Okay.
group
I
is
agree. That makes sense. I'm pretty sure that's right. I think what happens is that a lot of the people don't have their microphone working right now, so a lot of them can't actually talk.
Yeah. That's okay. Awesome, y'all. Let me go ahead and jump into another group. This looks great.
How do we highlight? I don't color code. I mean.
Oh, go to the draw versus doodle.
Uh-huh.
And then
you want us to draw the graphs and color code them?
Yeah, that would be great. That way we could kind of easily see what you were saying. I know it's gonna be a little bit funny because it's All right, great job. I'm gonna pop into another group, y'all.
What else? What do you guys like? Okay, wait. Oh. What else do you guys think we should add?
I can tell you why the bottom graph confirms the top ones.
Yeah.
Okay.
Bless you.
Thank you. Thank you.
If you take the 5 and multiply it by the 18, you get 90. And then when you look at the top graph, you end at 90 on 18 seconds. So then it like the bottom one confirms the distance for the top one.
Okay.
The top one could also.
Oh damn. Bruh. Shut up, Gino. What is wrong with this dog?
Is Bella finding a dog?
Yeah, she was.
I have a dog from Leanne.
That's her dog.
Edgar.
Yo, what happened to Randy? What happened, Bella?
Edgar.
That's her dog, she said.
Yeah.
What did he say? What happened to who?
To Randon? I don't know, bruh.
To Randon?
Yeah, what was that dude in our geometry class?
Yeah, and then he...
The one who used to always come in hella high and stuff?
Yeah.
Oh, he got arrested.
right here.
I got arrested for attempted murder.
Hello.
What?
Yeah.
Oh, my man's Randy, yo.
What? For what?
He went down because Asaya used to post him and be like, "Free my brother, he would have done it." I was like, oh my God.
What?
Hello.
Attempted
Oh,
murder.
we're good, Mrs. I know.
Hi. How's this going, y'all?
We're
Great.
done.
doing
See
good,
right
Mrs.
now. Hold
Lano.
up. I want to know about the
We're
murder.
doing
Hold up.
good.
So
Yo,
who's
free my homie,
the
yo.
screen sharing for this group?
It was Rosa, but we finished.
It's okay.
Oh, y'all already finished.
Yeah.
Yeah, so we're splitting the tea. So.
Wait, we not done because we didn't do the
Wait,
graph. Hold
yes,
on.
I put 18 represents the time and 5 represents the meters per minute and
And
90 is
the guys are
overall
supposed to show a constant
distance
rate.
traveled.
Awesome. Did y'all put draw a little visual for it? I'm not able to
Cool.
see it right now on my thing.
Yeah, we need to draw something, yo.
I gotta draw it.
Alright.
Because I'm supposed to answer.
I'm helping by talking about the color.
Awesome. I see the stuff showing up
We
there.
could put seconds. I see a heck of people putting seconds too.
But 5 what? 5 people. Oh, 5
We
feet
could
per
say like
second?
5 feet per second.
Duh.
All right, y'all. I'm gonna go ahead and head into another group. I see the stuff getting started on there. Yeah, if you could just get some graphs in there, that would be so cool. All right,
Alright.
y'all.
I'm gonna put
Got
feet
it.
per second.
Okay, we see. Okay, so let's say we see lot. What did he say? You said
It's because
that both graphs are consistent.
Yeah.
Okay. Graphs are consistent. Are consistent.
Yeah, are consistent.
You can say how for Frito's graph, the slope is the same throughout the whole. Actually, I don't know.
Yeah. Also, you could say Fritos,
So Frito's graph,
or you mean slope,
or
or
the graph has the same slope throughout. Has the same.
yeah, both graphs. You could just say both graphs have the same. Both have the same slope.
But Frida's is just like straight across though, so I don't think it even has.
Okay. So then just put. Well, then how would that show that they're the same?
Oh, you're right.
You could say that they both end at 18 seconds.
And 18 seconds, you said?
Yeah.
What else can we put? Kaylin or Evie, do you guys have anything? I don't know what else we can put, to be honest. Both graphs are consistent. Both graphs end at 18 seconds. I don't know.
So you could also say. I don't know.
Yeah, I don't know either.
Well, in Frida's graph, it shows how the velocity is consistent throughout the whole race. So maybe she's just going at that same speed the whole race.
So you said
and then Frida's graph is showing the distance.
Okay, so you said Frida's graph.
Hi, this group finished?
Yes,
Awesome.
we did.
Yay! It's because my phone is not not updating graphs we have. Awesome, y'all. We'll be coming together in just a bit. Let me just give the rest of the group some time. Awesome job, y'all.
Oh my.
Oh, so just do like Command Shift Z.
Yeah, no, I was tripping. I accidentally put V and I had copy and pasted my hook for English instead. So I was, okay, there you go. I don't know if you can see that. You can see me too.
We couldn't see anything. It was too dark. It was too dark.
Oh my god.
I could see the reflection in your glasses and the doorway, but that's it.
Terrible. Okay, did you get the link?
Yeah.
Okay. I don't know if it'll let you write anything, but you can try.
Hey everybody, we're just gonna wait for all the groups to come on back. Let's take a look at what we have here. Awesome. I wonder if we have everybody. We have about 11 of us back. It takes a minute or so to get everyone in. All right, we're getting more of us in. All right, so this is the group work that we got so far in this time that we did our group stuff. Go ahead and start like processing and reading through what similarities we're noticing here in the answers that our groups provided. Awesome, and I just think one group is missing the names, and I kind of forget who, but if whoever did this one group right here, if y'all can put your names on there. But what I'm noticing though, as I'm looking across, it looks like there's an agreement that the left graph represents the distance and the right graph represents, they say feet per second. I see that word being used here. Oops, I don't want to move that. Feet per second. This one says the other one represents velocity, which could be again feet per second. And speed, which could be again feet per second. So we're in agreement that second graph represents a rate, the speed, velocity, or, you know, over here this group put meters per second, meters per second. And I'm not exactly sure what this group decided on for this one here, but we're in agreement. So yeah, the second one is going to represent the rate. The first one represents position. Awesome. And now confirming it, I noticed we see some math here. For example, they did 18 times 5, you get 90. So the 18 at the bottom right here times the 5, like you're doing the base times height, which is kind of like finding the area of this square right here. It gives you the 90, which is the total distance. Now let's see if there's any ones that kind of show how this right here, the one on the left-hand side, verifies Frida's graph. So let's see. Right here, awesome. I see rise over run. So the slope of this graph is 5, which gives you the rate. So this one, like instead of kind of like typing out their explanation, I could see it with the way they annotated their graph. So they're saying basically the slope of the distance graph gives you the rate, which is basically her velocity graph or her speed graph, whatever it is you want to call that second one. Perfect. And then this one confirms this one because they did 18 times 5 is 90. So they visually showed that here. This group at the end, mostly like they have that visual as well, but it's like kind of explained and typed out here. They're showing the same thing that kind of this group over here did with group number 1 here. Awesome, y'all. Great, so go ahead and take a look and process that, and I'm gonna go ahead and bring us back together to synthesize this. So in some groups, I think some groups that I popped into were like, this totally reminds me of that first group activity we did with the graphs and the truck. So yeah, it's definitely related to that. So let me go ahead and bring us back to our slide. It is, and it's going to be driving our unit. It's actually going to come up again when we do our summative task, which is the mini final. That will be coming up the end of this week and also a little bit of next week, which is going to be the end of our module. But just a few reminders, and we did write this down in our notes, but remember the total area under a speed graph or any rate graph approximates total distance because we know that rate times time equals the accumulated unit. For example, it could be meters per second times second equals total meters, or it could be miles per hour times hour equals total miles. Rate times time gives you the accumulated unit. It's a big idea. And a lot of you applied that big idea in this group activity because you were doing that multiplication. You can determine the speed or rate from a distance graph by looking at the slope. So I noticed how that first and the last group looked at the slope and they were able to determine the rates. Like, oh, the slope is 5. That means the rate is 5. So she was going at 5 meters per second. So that's how you determine the speed, rate, or velocity, right? From a distance graph or a position graph if you look at the slope. So that's that second big idea. And then the third big idea, we didn't really use it here. It will come up in our, our summative, our mini final, but of course you could determine when an object stops in a rate graph or a distance graph. And if you look at the Khan Academy videos, right? If you haven't yet, please make sure you do that. Let me know if you do do it so I could give you credit for it. But if you looked at that, you could tell even more information. You can even tell when an object stops, turns around, changes directions, and so forth. So there's a lot more information you could tell from motion graphs. But this is just a great synthesis of the two main big ideas that's going to, again, continue throughout this unit. Now, let's go ahead and hit pause on that. So again, that was just application of our big ideas in your group work. I hope that it was worthwhile for some of you, especially if you're still trying to gain some understanding on this. But now let's go ahead and open up our notes. So there's some notebook paper and pencil. We're going to go ahead and try to talk about how do I find average velocity on a velocity graph. It's a little bit different, and I'm going to explain why. The learning target is I can determine the average velocity of anything in motion using a velocity graph. So basically what I'm asking us to do today is how do I find the average rate of a rate graph? That's like another way of saying it. Average rate in a rate graph, not a position graph, so it's a little bit different. Let me give you some time to write this down first off in your notes. All right, I'm hoping y'all got the learning target in and the title of what we're doing today. All right, so let me go ahead and do a drawing a distinction portion. So last time, remember we talked about how to find the average velocity on a position graph, and I took a screenshot of the video recording that I did. Again, if anyone needs a video recording, just email me and I'll send it to you. But remember, we found the average velocity in the position graph. All we had to do was take the 2 points and you found the slope between them, and that told you the average velocity or the velocity of the object in motion. So that was one thing we did last time, right? But what we're doing today is taking a look at this. So what we're going to be doing throughout these guided questions right here is notice that we have a velocity graph. It's a V right here. That means this is velocity. It's not a position graph. And we have time down here. Our goal is we're going to find the average velocity of a velocity graph. See how that's different? Previously, to find the average velocity in a position graph, all you had to do is find the slope. Now this is different because this is not a position graph. I'm asking you to find the average velocity in a velocity graph itself, the average of it. So that's the difference here, just to help you all see that difference. So we're gonna go ahead and take some time, to sketch this graph. And these are the questions that we're gonna go through. I'm gonna walk us through together. So this is like our notes right here. All right, so it says Dijon is late to his calculus class again. However, he is in no hurry. Below is a graph of the velocity. So for his velocity, meters per minute. So I'm gonna try to write that down. So it's meters per minute. So that means the time must be in minutes. I'm gonna put min down here. Cool. And it's going to be during the first 4 minutes of his journey. Yup, it ends after 4 minutes. Okay. Now, part A says, estimate Dijon's velocity at t equals 3.5 minutes. So remember, this is a velocity graph itself. So in order to determine the velocity at 3.5 minutes, here's 3.5 right here. 3.5, and then the velocity, because this is a velocity graph, is all we got to do is this. I'm trying to draw this straight. Let's see, what would that be? This is 2, 4, and that's 6. We could say that's like 7 meters per minute. Oh, let's see what the chat says. 5, 2, 4, 6. You won't want to go with 5? Oh, sorry. Yeah, it's not 7. It's not 7 because this is 6. Yeah, let's say 5, Rosa. Let's say 5. It's an estimate. I kind of went too above there. Let's say 5 meters per minute. Per min. Great. Awesome. That one's good. All right. Next, maybe let me just clear this. I don't want to see these lines. Yeah. All right. What are the appropriate units for the area under the curve? This one I'm going to go ahead and walk us through. Give me 1 sec. I'm getting some papers eaten up. Yeah. Okay. Okay, so the appropriate units for the area under the curve. So in order to determine the appropriate units, so basically, let's imagine that I'm going to draw like a box or something. I don't know. Let's say I'm going to draw like in the first half a minute. It's not straight. I don't know. Even with the line tool, it still doesn't look straight. Okay, so and let me do that. So the base of this would be 0.5 minutes. 0.5 min down here because minutes is down there. And then the height would be 20 meters per minute. So I'm just testing out a small segment of the area under the curve so that I could see what would be the units of the area under the curve. So then if the height is like 20 meters per minute, let's see what's in the chat. Oh, okay, we got 10. Yeah, you should get 10. Let me just go ahead and write this. Yeah, I think we do get 10. We're going to go ahead and have 10. And it looks like the mins cancel out and you get meters. 10 meters. Appropriate units for area under the curve, which makes sense, right? Because the area under the curve is going to be meters. It's a total distance. So meters makes sense. I know it's messy, guys. I'm so sorry. So again, these would cancel out. We get 10 meters. That's just as a test run. But if you do any area under this curve, you're going to, again, you know, if you cancel out, you're going to, again, just get meters. Okay. Now we got to figure out, now what is the average velocity during the first 4 minutes? Okay. So now we're going to try to move on to the meatier question here. So these right here are kind of like review ones, like just analyzing what's the area under the curve, so forth. Now, we need to, in order to find the average velocity during the first 4 minutes, let's remind ourselves, what is the velocity formula? So velocity is displacement over time. Sometimes if the object is moving in the same direction, displacement is the same as distance. And I think this object is moving in the same direction because the velocity isn't negative, as in it's not below the x-axis. So we could kind of, in this scenario, we could just think of displacement as distance and then over time. So in order to get the average velocity, and I'm going to put a little triangle there to denote average, average velocity is total distance over total time. So in order to find the average velocity, we need to first calculate the total distance. And how we calculate the total distance is we need the area under the curve. We've got to calculate the total area under the curve because that's going to give us the total distance. We already know the time. The time was 4 minutes. It was 4 mins for the total trip. We just need now the total distance, and then we're going to get the average velocity throughout the whole trip. So let's get to it. So maybe if you want to on your own, you could do it, but I'm going to also just do this for the rest of us. This is a little bit tricky because right here is not perfect. Oh, yes, it is. So now I need the area of this segment, which is again going to be 0.5 times 20. Great, this is also 10. Let me change my color. It looks crooked, but I think these are both, oops, 10. This is 10 meters, 10 meters, because it's 0.5 times 20 up here. That's 10, 10. And I think there's something in the chat, or no? Okay. Let me know if someone has an answer already. But now for this area right here, now this is a triangle, so we got to use 1/2 base times height. So the base right here is going to be 1, because from 1 to 2, that's 1 meter, 1 minute. The base is going to be 1 minute down here. So 1 min down here. The height is again just going to be 20 because this triangle's height goes up to 20. So it's going to be 1/2 base times height. So 1/2, the base was 1 minute. The height was 20. Oh, so this is also 10. That's weird. Also 10. It doesn't look like 10, but I guess it is. Let me know if I made any errors, by the way, y'all. Okay, so I so far have 30 meters in the first 2 minutes, and then it looks like addition stops, right, between 2 to 3 minutes, because the velocity is 0. That means there's no motion. Now let's keep going. Now I got to find the last area under here, which is this triangle again. And I'm going to use my other thing. So the base again is going to be 1 minute. From 3 to 4 is 1 minute. And the height now is going to be, and I think we said, I'm going to use my straight tool. It's going to be 10. The height looks like it's 10 because it hits right here. I don't need this anymore. So it's going to be, for this one, it's 1/2 because it's a triangle. 1/2 base is 1 minute times height, which is 10. So this triangle's, the last little baby triangle there is 5 meters of area. Meters. There we go. Whew. All right, so it looks like overall, Dijon traveled 35 meters of distance to get to his calculus class. So right here, distance is 10 meters. So now we got to do 10 meters divided by 4 to get the average velocity. By 4 minutes. And I know if we reduce that, that's going to give you 5/2 meters per minute. And I want to kind of know what that is in decimal format. What is that? I'm really bad with the quick. Oh, somebody got that. Why isn't it 35/4? Oh, it is 35/4, Kaylin. I don't know what's. Thank you for catching that. It is 35 total distance. I just wrote 5. Sorry about that, y'all. Oof. Yay, good catch. Yeah, I don't know why I wrote 10. That's weird. Brain fart. Redo that. Let's see what the chat has. Okay, good. I was like total distance. Yeah, I do not know, dude. I don't know. Sorry about that. We all have some, we got some permission to have some brain farts. Sorry about that, y'all. Okay, total distance. Yes, it's 40. 35. See? I don't know. We calculated 35. 35 was the total distance, as you could see in red. In case anyone else got confused, sorry about that. 35. Total distance is 35 meters over 4 minutes. Now I could, let me make this a decimal. I don't think this reduces. So 35 divided by 4. Let me check my phone. Unless somebody has that calculation. I got 8.75 meters per minute. I think that's good. Yeah, 8.75. I remember that number. Meters per min is the average velocity. Yay. So what we just did right now is we found the average velocity in a velocity graph. So that's drastically different as what we did before. So basically, again, how we kind of say this in general terms is we found the average rate in a rate graph. The average rate that Dijon is going is 8.75 meters per minute. So notice, like at the start, he was going 20 meters per minute, and he was going that 20 meters per minute for the first 1 minute or so. Then his velocity decreased over time here. It was like going down, 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 hits flat, and then goes back up. But on average, he's going about 8.75 meters per minute as far as the velocity goes. Perfect, perfect. Yep, and Sophia got the same thing. All right, so then the next question, first let me go ahead and keep this up in case anyone needs more time on this. The last question we'll go ahead and do quickly. Have 10 more seconds. And again, thank you so much for the corrections, because that keeps us all on our toes, including myself. All right, I'm gonna go ahead and clear this screen because I kind of hope we were all following along as I was talking. Let me clear this so that we can go ahead and answer this last part of the question, which is, how many times did Dijon travel at his average velocity during the first 4 minutes of his journey? So this one, again, we could do together. So 8.75. Like we kind of want to just find when he hits 8.75, the velocity. I don't know. So this is 8, this is 10. So it's going to be an estimate. This is 9. So maybe right here, 8.75. Something like that. If I just draw a straight line, you could kind of find where are the two locations that he kind of hits that average velocity. So it's about at 1.60 minutes, 1.60 of a minute, and then like 3.9 of a minute, almost to 4 minutes. So it'd be like 3 minutes and 50 something seconds. And then this one would be at 1 minute and like, let's say 40 seconds or 35. So again, this is gonna be an estimate. And again, because these are minutes, we kind of have to convert to minutes when we're talking about time. But that's how we would answer this last question. That's how many times Digen went at that average velocity that we just calculated in part the previous portion. Cool. Let me know if anyone has any questions. I hope we got this down. And I do have a quick, I think I had a checkout question. We could just jump into that before we get going. Oh, how do we justify it? So similarly, like, you know how I just drew my lines right here? So step one, I estimated where it was 8.75. I said it's about here, meters per minute. And how I'm justifying it is I'm using the graph. So I find where he crosses that in his motion. He travels at 8.75 meters per minute at around this time. And then a second time again over here. And that would be your justification. But you would kind of have to write that out. So first I found 8.75 meters on the vertical y-axis. Then I traced to where he actually travels at that amount. Then I went down to the time and I kind of approximated the time. And the answer should be 2 times. Yeah. Let's see what it says. How many times? Yeah, during the first 4 minutes. It looks like it's about 2 times that he hits that velocity. That's correct. And if you want to justify it, like be precise in the minutes, this is how you would make your estimates right there. Awesome questions, y'all. Let me know if I answered those. Let me write that down too, 2 times. All right, let me know if anyone has any further questions on this one before I jump into our checkout. All right, let me go ahead and clear this. And again, if anyone needs a recording, let me know. Happy to give it to you. Quick checkout, everybody. Thank you so much for your, engagement and so forth. I love this. I love the chat and all this stuff that's going on, the group work. It's been great. So in your own words, go ahead and describe, how do we find average velocity in a velocity graph? That's kind of what was the goal here in our lesson. Go ahead and use the chat, and it's okay if, let's say, you're still learning it. So in the chat, describe the process, like how do we find average velocity in a velocity graph? What was the process? All right, got some processes going on here. Find the total displacement or total distance over total time. It can be done by breaking the graph into squares and triangles. Yes, we totally need that total distance. Once we have that area under the curve, all you need is time and you'll be set. We find average velocity, yes, by calculating total area and dividing it by total distance. Awesome. We find the total distance traveled and divided by the time it took. Average velocity in the velocity graph by finding displacement and putting that into the formula. Wow, this is awesome, y'all. Right, I love this. Total distance is added up and then divided by time. Still learning it, but total area divided by distance. Total distance over total time. Awesome, awesome. We divide the total distance divided by time. So it's so interesting how everyone's kind of seeing like a different, like some people are thinking about different areas under the curve. Some of us are like just seeing it as distance over time. We got D over T, doing total area over distance. Total distance over time, still learning, but distance over time. Yes. Awesome, y'all. That's basically the main idea. That was the main learning goal. And again, if you're having difficulty, feel free to jump into office hours. I'm happy to help you out. All right, y'all. Thank you so much for this checkout and for this class. I hope you all have a great day. I'll see you all soon or whenever we see each other. Bye, y'all. Have a good day. I loved this class. It was fun. Yes, I'll send the class recording. Bye. Let me go ahead and just download this now. Bye. It's going to take about an hour though.